So today we're going to talk about sketching graphs of sine or cosine functions using transformations. So we know how all these transformations work from the last unit or last lesson, talking about stretches, compressions, shifting up or down, shifting left or right. But what we're going to talk about today is what happens when the length of one cycle is not measured in radians. So it's not one cycle is not 2 pi or whatever. How do we modify the equation to account for that? So this is kind of what we're going to take a look at. So when we got the London Eye, all right, nice Ferris wheel, all right. The structure is 135 meters tall and has a diameter of 120 meters, and it makes 2 revolutions in 60 minutes. So what we're going to try to do is take the information from this blurb and be able to sketch our graph based on this information. Just like we did in the last lesson, we write down kind of what we know and try to draw 3 horizontal lines. So one thing that we know is that max is 135 meters tall. So I can sketch that line in at 135. And sketch that in, and then at any time you want to hit pause, you can do so. All right, so there's that. And we know that our diameter is 120 meters. So that means that the top, from the top to the bottom, is 120 meters to the bottom. So we're going to have a little bit of gap. And our minimum height is going to be 120 meters down. So that would leave us with 15 meters left. And we can draw that line in. Got that. All right, so we know where our max is. We know where our min is. All right, and just like we had before, is we need to find our equation of axis. Well, we know that our equation of axis is our max plus our min divided by 2. All right, and I can think of that as 135 plus 15 over 2. And I can get that answer we can find that answer as 75 meters. The other thing you can think about is you could also say, hey, the radius, and we know what the radius is, it's 60 meters. Okay? So I know that my radius is 60 meters, so that we know that it's 60 meters down. That'll get me to the 75. Okay, and then if I take another 60 off, all right, so I can draw in another line. All right. All right. So there is my EOA. Okay. So question now is, where do we start? Well, we know that looking at our thing, it takes 2 cycles for 2 revolutions in 60 minutes. So I can think about that, my period, as 100 or 60 minutes divided by 2, so that is 30 minutes. So I know that if I went down here, let's say we start at the bottom, after 30 minutes, I'm back at the bottom. And then after another 30 minutes, I'm back at the bottom, another 30 minutes, and another 30 minutes. So I know that information. Other than that, now I can sketch my graph. And I can think about this as think about halfway across from 0 to 30, that's 15. I would be up here at my max. and then halfway across there, which is probably about 7.5 and 22.5. All right. And then I can sketch my graph. All right. And I can keep following along that same pattern. Okay. So that's not the terrible part. I think most of us should be able to feel good about that. What we're going to end up doing now is finding the equation. So we know that our EOA is part of our equation. We know that our amplitude, and our amplitude in this case, that's going to be our radius. Okay. So now we have 3 of the 4 key things. And the last thing here is our phase shift. So what we're going to end up doing is taking these pieces of information, all right, and then we're going to be making our equation. All right. So I think we're all good at that. I think we can do that. We can interpret this information. All right. We're still drawing 3 lines. All right. Okay. So it says here, determining equations, discussion graphs of sinusoidal functions where the period of the function is not in radians, the value k will have a factor of pi. And we talked about this yesterday, that our period, all right, is 2 pi divided by the k. And if we have the period, all right, we can get the value of k. So for example, we did the last question, we saw that the period was 30 minutes. Okay. Our k value would be that, or if I simplify that fraction, pi over 15, that would be the thing that we would put into our equation. Okay. So same thing for this one. If I complete one cycle in 16 seconds, the value of k is going to be 2 pi divided by 16 seconds, which is just pi over 8. Okay. And if I was finding k for this one, well, I need to figure out how much is one cycle. So my period here for this one is 60 over 3, which is 20 minutes. All right. And then I can say this is 2 pi over 20, which is pi over 10. So we can put that in our equation. All the rest of the transformations still hold true. The value of A, which is your vertical stretch, your value of your EOA, your vertical translation is the same. Your phase shift will be different, but it'll be just a number. And your period is going to be that. We're going to look at that. So what does this look like? So we're going to take a look at this graph and we're going to figure this out. So I'm going to try to zoom in a little bit here. Okay. So determine the equation of the line, just for thinking. So first thing is we're going to draw 3 horizontal lines. Okay. Like to look at that. And I can sketch there. There's my minimum. And then I have to find my EOA. Sometimes my EOA is nice. Sometimes my EOA is not nice. Okay. So my EOA, in this case, will be my max plus my min divided by 2. So in this case, this is 14 plus 3 over 2. So 17 over 2, which is 8.5. Okay. This is our vertical shift. So we're going to put that in as best we can. Okay. Okay. Here's my EOA. All right. Now we're going to find, so I'll put step 1. Step 2 is our amplitude. Okay. So our amplitude is the distance from the middle out and the middle down. So I could think of it as 14 minus 8.5. So I get 5.5. And I can check it the other way. I can take 8.5 minus 3. That's 5.5. That holds true. And now we have to find, okay, maybe look at our period. Okay. You can look at phase shift in a second. Okay. Okay. So if I look at my period, it goes from 0 to 12. So I know this is 12. In this case, it's hours based on the unit. But we know that we have to find our value of K. Well, our value of K is just putting 2 pi over that to get pi over 6. Okay. And then we'll look at our phase shift. And one of the things that we'll say is that if you don't have to choose a certain trig function, if it's sine or cos, you can choose which one. Cos makes more sense for this one, okay? And if I'm looking at this, that's a really good spot to start for y equals cos. This would be a good spot if I wanted to do the reflection, negative cos. So for cos x, here we're going to go right 12. Sorry, not right 12, right 6, my fault. Okay. All right. And now I build my equation. I can build my equation. All right. So y equals, my amplitude is 5.5, cos, bracket, my k is pi over 6, x plus x minus 12, and then up 8.5. Right? So there's my amplitude. There's my K from my period. That's my phase shift. And this is my EOA, my equation of axis. And that is it. So how do we get the equations a little bit different, but it's the same steps. Find your equation of axis, find your amplitude, find your period, but don't forget to find your K. So this is the important one that people tend to mess up. Okay. All right. So what happens when we go backwards? Well, it's the same thing. I want to find out all my different things. So if I look at this one, all right, I have my amplitude, which is 35. I have my equation of axis, which is 40. All right. I have my phase shift. So in this case, it's 0, so it's not moving left or right. And my K is pi over 6. And this is one that really kicks people in the butt. I need to find my period. So it means 2 pi over pi over 6. Okay, so think about dividing fractions. Okay, so 2 pi times 6 over pi, that equals 12. Okay. The only other thing is we have to think about our base function. So in this case, it's sine x. You could also think of that as a reflection. Okay, and we're going to talk about that in a second. But when we plot this, find my EOA, find my max and my min, and then put it in the period, right, in your phase shift. So again, I'm going to sketch in what I know, right? So I know that 40 is my equation of axis. I know that my max is 35 units up. And I know my min is 35 units down. Right, so there's my EOA, there's my max, there's my min. Okay. And then I know that it starts off at 0. So for sine, it starts off at 0 and it ends at 12. Okay, so I know that. All right, and then think about the middle of sine there. And for this negative sign, let's get down a bit there. So that's at 6, and then that's at 9, right? Because there's a vertical reflection here, and that's why it looks upside down. Okay. All right, I did my period of 12 units, and I didn't have to move it left or right. All right, and then I can keep following the same pathway. 24, 36, 48, middle of that, but there and there. All right, and by applying those little points, it helps you to guide yourself sketching it. So it's nice little loops. All right, and just think about it as 4 segments. All right. All right. And if I knew what these units were, so if I said X is maybe the time in seconds, okay, then I could say that these are seconds, okay, if that was given to you. Okay, so kind of to wrap it up. All right. Draw your 3 horizontal lines. All right, I got my max, I've got my min, I got my EOA. Sometimes how you draw those in will determine what's going on. All right, and then make sure you have your period as 2 pi over k, or if I'm solving for k, I have to do 2 pi over the period. So you have to think about kind of how those things mix up. And then be able to kind of plot points. To give that a go. All right, give that a go and see how it goes, and we will talk soon.